All right, so we're asking the question of how did the solar system form? We've taken the first step in the scientific method. We've collected empirical evidence about the problem, about the solar system. So we looked at its size, we looked at the fact that it has a definite plane, that everything seems to be moving in the same direction, that we have two types of planets, the inner rocky planets that are small, the outer gas giants. We have asteroids mostly in the asteroid belt between Mars and Jupiter. And then at the very edge of the solar system, we have these icy chunks, the trans-Neptunian objects. Now let's add some general knowledge to help us figure out what's going on, some general knowledge about space. And we'll mention a little bit of other scientific theories. So where does the material for the solar system come from? Well, it turns out that although we think space is empty, and it is in comparison to anything we're familiar with, if you took a cubic meter of even air from the Earth, it would contain trillions and trillions of particles. If you took a cubic centimeter from a typical region of space, you might find one single atom in there. Nevertheless, that one atom is matter, and space is so big that all the matter that occupies space adds up to be quite a bit of material. We call this material the interstellar medium, or the ISM. And what is it composed of? Well, it's composed of 99% gas, mostly hydrogen, about 92% hydrogen. Most of the rest of it is helium, and there are traces of other gases like oxygen and carbon dioxide and ammonia and methane, and about 1% of it is solid material that we refer to as dust, not because it's the kind of dust that floats around in your room, which is actually little tiny bits of dried skin that flakes off of you and the other people in your home, but because the size of these grains is similar to the dust that floats around in our rooms. Now, this composition might sound familiar to you. 99% gas, 1% solid. We saw that's the composition of the solar system. And maybe that's hinting at some connection. In any case, here is what a dust grain, a grain of interstellar dust looks like. It's actually not little bits of organic matter. It's actually tiny, tiny little bits of rock that are coated in ice. And remember, ice is anything that's frozen in space that's liquid or gas at room temperature. So this ice could include water ice. It could also include frozen carbon dioxide, frozen methane, and so on. And it's all very small. The scale here is 1 micrometer or 1 micron. That's a millionth of a meter, or a thousandth of a millimeter. So these are very, very small. Nevertheless, they are solid material. And in fact, there's so much of it out in space, even though it's spread so thinly, that in places it blocks out the light from distant stars. And so if you look at the Milky Way, there are these dark lanes that seem to run through it. The biggest one is called the Great Rift. And that looks like an area where there are no stars of the Milky Way. In fact, that's dust that is blocking out the stars behind it. And we can see this kind of dust in other galaxies. It's in fact everywhere. The universe turns out to be a very, very dusty place. Now, what's interesting for our purposes in trying to understand the solar system is that there are a lot of places in space where the interstellar medium has actually been pulled together into big clumps that are cloud-like objects of gas and dust floating around in space. We call these nebulae. The singular is nebula. Nebula is a Latin word that simply means cloud. Typically, these nebulae are about 10 light years across, but they can be dozens of light years, even hundreds of light years across, depending on their size. Now, remember, the size of the solar system is only about 3 light years, so even a fairly small nebula is bigger than our solar system. There are 3 types of nebulae, and we'll take a look at those in the next video.